All right, good afternoon, everybody. We're here, Blake, Brian, and I, to present on some software that we've been working on to automate and scale penetration testing and push that down to the developers inside Cisco. And we're here to hopefully talk about open sourcing it and giving it back to the community. So the title of the talk is Scaling Security Assessments at the Speed of DevOps. Yeah.
Hi, so my name is Blake. My name is Blake. I'm primarily a Ruby on Rails developer, and I've got a long history of doing web penetration testing. So I've got some skills there from, attack and defense perspective.
Hi, my name is Brian. A very similar background to Blake. We both work for a group called AppSecUSA, which stands for Advanced Security Initiatives Group within Cisco. Again, Ruby on Rails developer, a lot of web security, pen testing, and proactive defense.
And my name is Roger Siegel. I've worked for Cisco about 10 years doing penetration testing in ASIG. I work for TIP now, doing threat intelligence, and I'll throw out the buzzwords, big data analysis type of stuff. Ruby on Rails, or Ruby developer, Python developer, do operations and config management. And then I live in Asheville, so I would be remiss to not mention that I love IPAs. So it's a beer city. Got to stay true to the roots. So first off, I'm going to introduce what this platform is and talk about the motivation behind it and why we developed it inside of Cisco and our basic needs. Everybody knows this. It's been hit on throughout the conference, but I'll run through it really quickly. Looking at development trends and how that is working in the industry today and the trajectory there. You know, the key terms that people are looking at are agile, thinking about, and these are brief definitions, adaptive planning, early delivery, continuous improvement, rapid and flexible, right? And then we look at what's happening with DevOps, where we have a coordination between our IT facilities, our QA teams, and development efforts in general, with the goal of just rapidly releasing products as fast as you can with new features and functionality that the customers actually want. And then we look at what continuous delivery is doing and building and testing and releasing on this frequent basis in some platform. And what you do is you look at the common denominators here, and all of it is you're looking for speed and agility, the ability to execute on your goals faster and deliver it to your end customers as fast as possible. And this can be an enemy for security, right? And even going further and looking at the development trends in Cisco, it's historically been a waterfall model. And it's moving more and more towards an agile development approach. But this microcosm of Cisco actually replicates what's happening in the real world, where we have a bunch of developers working in multiple business units, and they're going to use a variety of tool sets. We don't standardize on one tool inside of Cisco. We don't say that you should be using Git or you should be using Subversion. You can make those choices on your own. And you could be using any type of CI system, whether it be Travis CI or Jenkins. And they go out and if you're deploying a service, you could be using Amazon EC2, you could be doing OpenStack, you could be doing Rackspace. You could be doing an embedded system like an IP phone or a router or a switch, right? And so we have to engineer our solution to actually adapt to this environment. And then over time, they make these releases of software and code and services, and they could be vulnerable at one point in time, or they could not be vulnerable at any point in time. And that changes rapidly when they're starting to move to an agile approach. So everybody should be familiar with this concept. And for a while, the way that we did this 10 or so years ago was that we would have these checkpoints where we would run third-party tools like Qualys or some others out there to do our vulnerability checking. We would have third-party penetration testers come in and try to break our code and our software releases, and we would react to what they find. And then we would spend a big portion of time with internal penetration testing team like ASIG to go through and find out the vulnerabilities in our code pre-release, okay? The problem with this is that it just doesn't scale, right? What was happening is that there was a security checkpoint being thrown up in the middle of development, and everybody was being halted. And so 6-7 years ago, there was a push to make this secure development lifecycle where we would sprinkle security throughout the development processes, adding in threat modeling and some other good things for developers to actually follow, and it would limit the number of vulnerabilities that are found in our products and services. And so we wanted to move to a model like this, where you could do these security checkpoints at any point in time, depending on the maturity of the software and what has been found or whatnot at that point. And we wanted to push that down to the developers and give them guidance on what tools they could run on their own before they got to the penetration testing stage where someone like ASIG would go and focus on it so that the development teams could find the low-hanging fruit. That's where we were. And the problem with this is that security testing is just hard, right? We're trying to take a specialized knowledge and push it down to developers, and we're assuming that they're going to be able to have the time to be able to learn all the tool sets, right? You can have things like the continuous deployment model where the code is rapidly changing and they might not be able to react to that as fast as possible and run all the tools that they need to run and still make their gates. Or they're going to be working in isolated environments where the testers could test similar things and find similar bugs in isolation, but maybe they're not sharing that work between one another. And so it was difficult to find a centralized platform to exchange all of these testing ideas and all the testing that was happening inside of the organizations. Continuing on the security testing's hard emphasis, looking at the different security tools that we were requiring developers to run, there was a lot of variation in there, and penetration testers and AppSec professionals know this, is that the skill required to operate some of the tools is very minimal. Some of them are very complex, right? They're not developer friendly. And there are coverages and gaps in detection. You can have false positives, false negatives. You need somebody to be able to interpret those results and tell you what flags to run with a particular tool to get the required output that you want. And even varied output formats where there's XML, there's JSON, there's unstructured. And it was really hard for someone to interpret those results from the developer level to know if they should care about a particular output from a particular tool. So we wanted to find a way to centralize all of that and simplify it for a developer. Instead of having a situation like this where everybody's testing everything, right? And nobody really knows what's going on. So a year and a half ago, is that about right? Yeah.
All right.
Does anybody know where that's come from? War Games, awesome. And the reason why that came from War Games is the project used to be called Whopper, but some people thought that that reminded them of Whoppers, right? Hamburgers. So they wanted to change it, so we kept on the theme and we went with NORAD. So a year and a half ago, we embarked on this idea to create what we call NORAD, then was Whopper. And we call it a vulnerability clearinghouse. It's a framework that allows us to aggregate the results of multiple security testing tools to be able to determine an asset's posture, and we'll walk through what an asset actually means. We don't want to rely on any one particular tool because of different tools give you different results, whether they be good or bad, and we want to run whatever we want to run in our environments and make it modular and to accommodate multiple tools, be able to plug them in, whether they be vendor specific or homegrown, and we want to be able to prevent vendor lock-in. So maybe we want to run Qualys one day for a particular product, or maybe we want to run Nessus for another product, or maybe we want to run both of them and then see what both of them find and then correlate all those results. We also want to be able to evolve our security assessment automation with new tools that come out based on new threats. So somebody out in the industry might find a new vulnerability and they might write a quick Python or Ruby script to test an asset for that particular vulnerability. We want to be able to pull that in really quickly so that we can react and respond. And really this is all about embedding security testing into the development and deployment lifecycle. So we need to make sure that this can be API driven and it fits into Agile and DevOps best practices. The last one, and this is why we're here today, is that we want it to be community driven and supported, meaning we want to give it back to the community and build a community that will help create security tests and make the code open source, and people can do whatever they want to with it. So I'm going to quickly talk about the deployment models, and then I'm going to hand it over to Brian to go through the architecture and discuss some of the different features and give you some demos of this particular tool. But when we look at how we need to deploy this inside of Cisco, there are a few different ways that we could have done it, and we do it. One is as a cloud service. You can think about security testing as a service for the cloud, where you can just go to a web interface, you plug in your assets, you tell it what tools you want it to run, it goes, spawns it off, handles all the scaling, and pulls in all the results. So it's plug and play for our end users. We also have to think about a hybrid deployment where some of our test networks may not be reachable from our cloud instance. So we have to be able to accommodate that and have them set up what's called a NORAD relay, which we'll go through in a minute too, and still be able to test their assets in the private network, but pull the results back up to the cloud. And then there is the on-prem solution where you can just deploy it on-site Everything's bundled up for you, and you don't have to worry about any interaction with our cloud, so you can run it standalone for anything. So I'll hand it over to Brian, who's going to talk about the architecture.
Cool, thank you. So yeah, kind of digging down into how NORAD works. This is a general view of what our architecture looks like. As you can see in the kind of mid-right section where the Docker logo is, the whole idea of NORAD is to be able to spin up a lot of tests quickly, scan multiple things all in parallel. So we utilize Docker for that. All of our test content is wrapped in Docker images, and then those get spun up into containers. And then they reach out and they hit the customer network located down here. And then once those tests are done doing whatever they have been instructed to do, they hand the results back up to the Rails app, which is there in the center. That takes care of orchestrating when tests get kicked off, viewing results, things of that nature. And then to move back even further, everything is fronted by HA proxy. So as a customer, you're only ever reaching out to norad.cisco.com. You're not worried about having multiple endpoints that you need to reach out to. Down in the lower portion of the cloud here, we have RabbitMQ. That's for our relay, so that we can send messages down, and I'll discuss that in just a moment. And then we also run our own Docker registry. That's where all of our test content is stored. We are trying to build in the idea of having private registries that you can opt into. So if you want to run your own registry and have your own test content without going through the official NORAD stuff, you'll be able to do that. That's not quite there yet, but it's in progress. Of course, everything's stored in a database. We have up here in the upper left, Console and Vault. Console is for our service discovery so that we can scale all of these different parts of the cloud whenever we need to. And then Vault is used so that we're storing sensitive information. For instance, you may have credentials that you need to give us to log into your machine to test these things. We use Vault to make sure that those credentials are stored encrypted at rest. So here we have an example customer network. Very contrived, but we wanted to show maybe semi-practical example. So this example is running on AWS, and that's kind of your virtual private cloud there. The upper portion is public subnet, so these would be anything in there are machines that can be reached from the public internet, of course. Down in the lower section is a private subnet, where obviously there's some type of either NAT or firewall blocking any access to those machines. And we'll go through how we're going to be able to test all of this. I should say the machine up here in the public net only has SSH running, and the machine down here has SSH and a web server running. So before I get into some of that, I'll talk about a little bit of terminology just to make sure everybody knows what I'm talking about when I say some of these words. We have the idea of organizations, and for us, an organization is just a logical grouping of machines. Users are allowed to create as many organizations as you'd like, group your machines however you like. And a machine is really anything that has an FQDN or an IP. If we can reach it in that way, we should be able to test it in some form or fashion. And then security tests are the tests that are wrapped up in the Docker images and are the ones that get deployed in the Docker cluster. So I'm going to show a quick demo here of how we can actually pull in the machines to our organization here. Let me pull up the video real quick. So we're starting with that cloud I just showed you. And the first thing we're going to do is create an organization. Like I said, customers are allowed to create as many organizations as you like. This one we're going to name AppSec 2016. And it might be a little bit hard to read what's typing, so I'll try and say everything that's being typed in. And then from there, you can we'll set this to our default organization so that when we log in next time, that'll be the organization we actually go and see. You don't have to set a default organization, but this would be what you would see when you come in. And as you can see, we don't have any machines registered right now. So what we can do is we can go in and we can actually provide our infrastructure as a service credentials. This time it's going to be AWS. And we'll put in the information necessary for NORAD to log into AWS for you, and it'll actually pull out all of those machines and register them with NORAD. You can also register machines manually. We just wanted to show how this could be automated as well. So there, we've saved the credentials. Now we'll just go down and we'll actually hit Discover. It'll kick off a job to reach out to AWS, and it will pull in all the information for us here. So we'll go back to our machines, and we can see we've pulled in 3 machines. 2 of them, I've already talked about, the web server and the SSH server, and I'll talk about what the 3rd one is here in just a minute. So we've got our machines in NORAD now, and we want to start trying to scan them. The first thing we'll start off with is just scanning our public assets, which is that one machine that has SSH access. And it's pretty straightforward. I mean, like I said before, you would send a request to norad.cisco.com to our API to tell it to scan a given machine or an organization. And then that command is given down to the Docker cluster. The Docker cluster spins up a container, hits those assets that you've instructed to scan, and then takes the results and stores them back up in the API. So a quick demo, watching this, right, it'd be pretty straightforward. The device under test is up top. We just send some type of message to it, test it, and store the results back in the cloud. So I'll show you how that is done. Maybe, if I can... So here we've got our machines again, and we're going to have to apply some security tests. By default, we had Qualys enabled. That's an internal Cisco thing. The open source wouldn't do that by default. In this test, we're going to apply a tool called vols, which actually SSHs into your machine and scans for known vulnerabilities based on known CVEs. So now we've seen the machines already populated. We're going to go ahead and add some descriptions just so because we can. And that way it'll help us as we're, if we've got a long list of machines, being able to know what machine we're looking at any given time. This one just says public-facing machine with SSH access. And I think this one's just going to say private machine with web access. Yep, with web app. Save the descriptions. So we set the tests at the organization level, which means they get applied to all the machines in the organization. You can also apply tests at the machine level that will only be applied for that given machine. Like I said, since we're using a tool that requires SSH, we go in and we can provide our SSH credentials for each machine. We are working on the ability to add one SSH user and SSH key for a whole organization rather than having to provide keys for each one, but that's not quite finished yet. But this will just step through each machine and add the keys here. Oh, right, yes. Blake brought up a good point that I forgot to mention. Everything I'm doing in the UI is available through, we have an API. So it's actually, that's how our features are driven. Everything gets put into the API first. The UI actually just consumes the API. So anything you see me doing here is absolutely doable, scriptable. So while this might seem a little painful to have to go into each individual machine, you could easily write a script to do all this. So now we've got our key in all the machines. We're going to go ahead and kick off a scan for that given machine. And then we'll take a look at the results. You'll see that there are no results right away because obviously this test is going to take a little bit of time. And when no results have come back, it's light gray, which you probably can't really see on there. And you can see, no results are available. We'll give it a minute here, and the video is sped up, and then we'll refresh, and we'll see the results have come back. And the red line indicates that there are some failures. So now we can drop that down, and we can see exactly what failures have occurred, right? This is actually the output that was run from the tool itself. You can also drop down and see a more larger description rather than just the title. I'm not sure if you guys can read, the titles on these are just CVE numbers. When you drop down the description, it actually describes what each of those CVEs correlates to. And then you can just collapse each one of them as well if you need to get through a bunch of them. And I think that's the end of this one. Maybe. Yep. Okay. So that was good. And we can scan public assets, which is great. But, you know, we've got no way to reach this private machine right now, right? Like, even if you could craft a packet to somehow get in there, it's not going to go all the way to that machine. So the way we have got around that is we've developed something called a relay. And basically, it's a machine that's deployed within your network that's running Docker, and it connects up to a RabbitMQ queue. And as commands are sent to the API, they're, instead of pushed over to the main Docker cluster in our cloud, they get pushed down to this machine here. From that, they spawn off Docker containers and hit your assets individually, and then send the results back up to the cloud. So we can see it gets sent down to the relay first. That relay then decides it's going to scan that server, and it's going to send its results back up. There are a few connectivity requirements with that, but we were trying to make it as easy on network administrators as possible. So all of the connections are outbound, which we felt was a little bit easier than having to open up ports in your firewall to allow inbound connections. So those are the requirements for allowing the relay to connect back up to the cloud. And I'm going to go over how you would do that here, both setting up a relay and then having it scan. There's a question.
Right there.
Oh, yes.
So one of the problems with this is, as you saw in the previous slide, you're putting in, access keys, SSH keys of a private machine,
Yep.
thereby exposing the SSH. Now it becomes a security vulnerability in itself, over to the UI of this other machine that is sitting outside.
Sure.
The private cloud.
Yes.
We technically do not want to give SSH access to the machine at all.
Understand.
Expose SSH to any other machine.
Right.
Which is a problem with security.
Sure. So one thing we've done to mitigate that is we have the ability to store the SSH key on the relay itself, so it never actually goes to our cloud. You just tell it when the command comes down, use this key that's stored on your machine, that's stored in your private network. So that way you don't have to.
Wait a second. Let me explain this a little bit further. So you absolutely do not have to do any tests that involve SSH at all. If you do not want to give any credentials, then you can write security scripts that do nothing along those lines, right? And you can integrate those into the system. That's one option. The second option is that all these, so connectivity requirements, when you talk about exposing SSH externally, you're not exposing it externally outside of your enclave. The relay is the only one who needs to be able to SSH over, okay? For credentials management, we do have an agent that we have developed that you can put on the system. So there's always this balance with system administrators. When we talk inside and outside of Cisco, where some of them want an agent, some of them don't want an agent. So there's always the trade-off between I'm giving you my credentials and I'm trusting you to store them somewhere, or I'm putting an agent on my system and the performance may drop because the agent may be using too much resources, right? So we have the ability to do both of those options. The agent portion of it is not being released currently because of the requirement, or because of the business units that we're working with inside Cisco want that external approach, right? When we talk about storing credentials in the cloud, that's where we leverage Vault. They're secured at rest and then sent down and unencrypted on the other side. Brian also mentioned the storage of credentials on the agent. So there is a varied profile that you can choose from based on your risk management strategy on how you want to do scans, if you want them authenticated or not, agent or not, all of these options you can choose. Does that answer your question?
Yeah, well, so the agent-wise, is it work in a subscription model where it sends the data to something like Logstash or something like that, where that data is being consumed real time, analytics or something like that? Consider that model the reverse model?
Yeah, so from an agent model, the results are still sent back to our scanning engine, right? Whether that be if you want to use the cloud deployment model, then that would be sent to the general purpose cloud. But you could do an on-prem deployment, which would just go directly back to your NORAD instance that you deployed on-prem. If you want to pull those results out, the API is available to script it up, pull the results out, and send them back wherever you want to send them. So, we can talk more later if you'd like to. So.
Sure. Okay, let's see here. So yeah, this is going to be scanning private machines. The one thing we're going to do, because this private machine that I had mentioned before had a web server running on it, we're going to go ahead and add a security test to do some different type of scanning. I can't remember off the top of my head what it is. Oh, that's right, we're going to use Zap Passive. So yeah, we'll go ahead. Oh, this isn't on the main screen. All right. Have all of them not been done?
No, they've been approved.
Okay. So yeah, as I was saying, this machine is going to be have a web server on it as well. So we're going to add another security test to it. We're just going to search for our tests. We're going to use the Zap Passive test. And once we add that, now that will only scan, we will only run Zap against that given machine. We'll also run vols because we have that set on the organization tests. From there, now we got to go deploy the relay. And we're going to flip over to the machine. That's that third machine at the very top listed here. And I think I named this NORAD relay. I probably should have cut that out. This is why I like voiceovers. So yeah, we'll flip over to the shell of the relay machine. And we've developed two packages to help you install this relay. One is a Debian package and one is a RPM. Those are currently the two things we support right now officially. It would probably work on other instances as well, but we don't have any deployment packages made up. But we're in the machine here. If we do an ls, we can see we've got the NORAD relay package, and we're just going to do a install of that. The one thing that I haven't mentioned that we'll use here in just a second is the idea of an organization token. That organization token is meant to be kind of like a shared secret amongst your organization, and you can get it right there. That is going to allow us to verify that this relay is able to join up to our organization. Without that, you wouldn't be able to just add any relay to the NORAD cloud. Once we put that in, all we have to do is start up the service. And Docker does a bunch of image pulls and things. And this, we're just checking to make sure that it's actually running. So we're doing a Docker PS. We can see the relay is running. And then we're going to flip back over to the web app. And now the relay has registered itself, but it won't be used until you actually go and verify it. And we have that key signature there in the middle to allow you to actually go onto the relay machine, verify the key is who it says it is. You can also set it to auto-verify if you trust that anything is going to, you're in a pretty secure network and you don't mind relays adding themselves. We've kicked off a scan for the private machine. It's now going to run vols and the Zap Passive. And then we can flip back over and we can watch the logs of the relay to make sure that the job is actually coming down. A lot of this is blurred out because there is some sensitive information that gets passed down. But you can see, we're pulling those images and we're starting the scans. We can flip back over to the UI and then we can see results come in here in just a second. And again, we've intentionally made these vulnerable. And so you can see the various tests that have failed there. And the information's accessible just like it was previously. All right, get back to here. So those are kind of our main deployment models. The other thing that Roger mentioned was the enterprise model, and this is how we actually do our dev box as well. Everything is just packaged up into its own Docker container, and it makes it pretty quick for spinning things up. But this has been kind of low on our priority list because our customer is just Cisco right now. So this, before we release this to the open source community, we will have a little bit of cleanup to do with this, but that is the plan we have for allowing people to have on-prem solutions rather than having to use our cloud solution. And from here, I'm going to pass it over to Blake, and he'll talk about the security test content.
Yeah. Okay. So Brian has kind of introduced the platform itself, how things are run, where we're going to manage assets, store the results of the scans and things like that. So now we'll get into how do we build our test content. We wanted to provide I guess a test content platform engine, however you want to put it, that was going to be flexible and extensible so that we can enable people to quickly and easily develop new test content that is either a general use case that lots of different groups can use, or if you have something that's custom to your deployment, your needs, you could write those types of tests as well. So as has been mentioned a few times, all of our tests are run inside of Docker containers. So therefore, all of the tests themselves are stored in Docker images. This gives us a few advantages. Some of those would be every test is going to have its own isolated environment. So it's going to be a short-lived base clean environment for every test. So the test writer can know that the state of the machine is always, the machine that's running the test is always going to be predictable. Another advantage is for those of you who aren't familiar with Docker, you can start with a base image. And so what this means is someone could do some work to create a Docker image. You need everything that they have done solves, let's say, 90% of what you need, and you need to make just a little bit of a change. So you can start from a base image that has already been made, and then go from there. And we actually have a base image that we use that comes bundled with a Ruby gem called Beacon, and it's just kind of like a local library that a test writer could use to facilitate interacting with the API as well as starting starting other threads for the actual test to run and things like that. The general idea of making a test is you're either going to start with an existing tool like Nmap or Zap, like if you're going to do a web test, or you can create something completely custom. So if you have a need or something you need to check that isn't going to be, that some other tool isn't going to help you, you can write your own thing. As far as getting tests into the system, right now, all tests, since they're currently all being written by us, go through our review process. So a test comes in, we review it. Once things look good, it's going to go through our CI pipeline, which is going to update our documentation server for the test. It's going to add that test to the registry so that relays in our Docker engine can start using it. And then it's going to make that test available in the API itself so that you can actually use it. So to kind of help make test content creation easier, we've got a scaffold generator, so a little command line tool that if you choose to use it, it can kind of generate all of the boilerplate you need to create a test. Hopefully is pretty simple to use. As you can see, here's the invocation line, and then a few of the options. You set the test type. So we have currently two different kind of types of tests in the system. There are the evaluative tests, which are tests that are going to be a pass or fail type state. And then there's also informative tests. And those types of tests might be like a port scan or listing out the accounts that are available, things like that. Things that aren't necessarily a pass or a fail, but it's a task that you have to repeat over and over that you would like to abstract out a little bit onto the platform. You also tell us which registry the test is going to live in. Right now, there's just the one registry, but as Brian mentioned, eventually we'll support the ability to pull down an image from any registry you choose, or even, I guess, your local Docker instance that you got running. If there's some images there that are available, you could use those too. Version, pretty self-explanatory, just something to tag it with. Which base image you're going to inherit from. So as I mentioned before, we do provide a base image that's going to have our NORAD gem installed, but if we also have Nikto, Nmap, and a few other tools that have been wrapped already. So if you need to use that tool and just have maybe a custom use of it where you care about a certain bit of output that a different test wouldn't need to use, you could inherit from that image instead. And then finally, there's the authenticated versus the unauthenticated version of the test. So I think as the question was brought up, what if you don't want to grant access to this testing tool to your system? If you just want to run unauthenticated tests, that's fine. We have two different types, so it would be up to you as a user and then as a test content developer which type you are going to create. So just an example, here we're going to create a simple ping test. So this test is going to work in such a way that we're going to, when we run it, it's going to try to ping a target. If the target's up, the test is going to pass. If it's not, then it will fail. So a very basic test, and you can see here what's going to be generated for you. So we have the Docker file, and I'll get into each one of these in more detail, but the Docker file is going to describe the image that this test is going to run within, so it's going to kind of set up the test environment. We have a README file for our documentation. The manifest contains metadata that the API is going to use so that it knows how to run the test. The test wrapper, this is the script that the developer is going to write that kind of has the logic for parsing out the results to determine a pass or a fail. And then finally, we generate what is needed to run tests in terms of our test harness. So it sounds kind of crazy, but we want to provide the ability to verify that this security test being written tests what it says it's going to test. So we have some CI in place that can help you as you develop your test to make sure that if I'm testing against a machine that's secure, I should get no results. If the machine is supposed to have a vulnerability, this result should show up. So here we have the Docker file. This is again a very simple one, but to be honest, most of our tests look a lot like this. Once we have all the stuff that we can inherit from, we don't have to do a lot of custom work each time we want to automate a new test. So this is just telling it what image to start from. So we're starting from our base image. We're going to copy our wrapper script over onto into the image. And then this entry point sets when we start this image as a container, this script is going to be executed, and it will receive any arguments that we pass down to it. The manifest file just has the metadata, like I said, of what the API is going to need to know how to invoke this test. Of interest are the prog args. This is the arguments that the script is going to take when it's started, and then we're going to set default values so that if, for the most common use cases, a user won't have to do any sort of configuration whatsoever. And then finally, the category, the black box versus white box, or unauthenticated versus authenticated. So in this case, we're going to set up to pass in the -C flag from ping, which is going to limit the number of attempts. We're going to set that by default to 4, And then this target attribute is going to be passed down from the API. So this is the IP address or QDN of the machine we are going to test. Then we'll set up our README. Every test is going to have a README with it. That way we can describe what's going on. We can provide a sample configuration, explain what each option is for. And then we have, this documentation is different from that, but this is an example of our documentation for the ZAP passive test. So if this test that we're writing here were to be merged in, then it would have its own section here in our documentation as well. So you can see here some of the other tests that we provide. And I'll go in closer on this to the different parts, but this is an example of the entire test for this ping test that we're going to write. This includes starting ping in the background. This includes parsing the results. It includes packaging up the results and sending them back to the cloud. And again, even though this is just an example, this is representative of the majority of our tests. Most of them, once we get to this point, this is all that's needed. So we'll start here, and you can see that since we're going to use the beacon package for convenience, first we will require that. We'll set a timeout. There's going to be a default value if one of these isn't set, but we think that a ping test should be pretty quick, so we'll set a short timeout. Then to tell beacon what tool to run, we're going to run ping, and we're going to pass the arguments that we get from the cloud down to that, and then we will start that. And once we start that process will go on in the background. Once the background process is complete, we will execute this bit of code. We're going to get past a file handler. This file handler is going to contain the output and the results of the test that we just ran. If we need to, we can check the exit status of that process, or, which is what we're going to do here, we can process, we can look for a certain string. I don't know how visible that is, but that's just looking to see if we had a 100% packet loss. And if it's there, then we're going to set the state to pass. I'm sorry, to fail. And if that string isn't present, then it must be up. So we'll say that it passed. So at that point, we've set up our title of our test, our description, and we've determined our result. So to send it back, we create a result class. This will handle sending the result back to the cloud. It will handle signing the result so that we know it came from a valid test. It does a lot of stuff in the background that we don't have to worry about here as a test content developer. And then once we've created that result, we're just going to post it back. And then it will be on the way, and it will show up in the UI like Brian was showing earlier. Just a quick exposure to the unit testing we do for each of these tests to verify that they test what they should. Each test is going to have a secure machine and a vulnerable machine. And you create this file, which is mostly generated for you. You just fill in that for a vulnerable machine, we're going to expect to see some results, and for a secure machine, we won't. So just a little bit of a convenience there to verify that things are working as they should. As far as the types of things we have available as test content, we can do third-party stuff like Qualys. We leverage some open source tools. We do crypto testing with Nmap and SSLIs. Vols is one that we showed in the demo. ZAP Passive is a web proxy tool developed by OWASP. And then we also run, we use a tool called Server Spec, which I will break down a little bit more in a moment, but it's a tool that can be used for verifying the configuration of a server. And then we also have the idea of, so within Cisco, they have a CSDL lifecycle. They have certain requirements that are defined. And so within the application, this isn't functionality that we showed, but you can actually take this test content, link it up to a specific requirement. So and in our case, that would be a Cisco requirement, but you could also create a separate set of requirements that fit with what you're doing, and then link them up to different tests. Server spec is a tool that we use heavily for verifying server configuration. It's an open source tool. It's a domain specific language for writing tests writing customized tests. We want to be sure to give credit to the creator of that. If you'd like to check out the tool yourself, you can see it there. And here's just a couple of simple examples, just to make sure that, let's say, an SSH config is set up in a certain way. This test will run authenticated on the box to make sure that your configuration is correct. Just a quick, we showed some of the documentation before, but in addition to having all of the test content there and available, all of our API documentation is here as well, and then as well as instructions on installing the relay. And then I think, yep, Roger's going to talk about the rest of the open source plan.
So the key to all that was that we wanted to have this really flexible platform where we could plug in tools very quickly and efficiently, whether they be commercial, open source, homegrown, and have a consistent way to feedback those results into our system so that we could push all of that knowledge that penetration testers have about their particular tools. They can go ahead and create that test and then push it down to all the developers and kind of amateurize the cost, right? So not all the developers need to know every single tool they need to run. They just need to know when to run the particular tool. And we're actually working on that problem as well. But all this is leading up to, this is a project that we wanted to open source because we really want it community driven. We want individuals to contribute their security tests, other Docker containers, to NORAD so that everybody in the community can benefit from it, whether that be from a cloud scenario, whether that be an on-prem deployment, or your cloud scenario with a relay or any mixture thereof. So we are going to be releasing the code at GitLab under groups NORAD. It's not there today. I've spent the last 3 days talking to lawyers. So there is an agreement, though, that we are going to release it within the month. There's a couple of features that we want to get in there as well. We're currently working on service discovery, and that's going to lead up to, once we know services, then we can actually make suggestions on which tests you need to run based on the services that you have available today. It's coming down the pipe. So we're working on that as well so that the developer doesn't need to actually know everything about what test to run. We give them suggestions, and then they can say yes or no and go from there. And we'll probably map down to requirements as well. But this release of code will actually be several different repos that get this to work. And this is just an eye chart of the repo map that's going to be there, from our beacon gem to our specs library, the API, which is the core of the code, and the UI, which is the user interface that Brian demoed. Key to note that you don't have to use the API at all, right? You can script everything you want from the API. Docs is our docs that we automatically generate. The dev box is basically the enterprise install, but that's what you would use to do the development for as well. The relay package, there's a Python SDK that one of our engineers has actually written. And then a lot of the work is really going to happen in the Docker images repo, and that's where all of the security test content will get written and merged and tested and then pulled back in to be used in the application itself. So we're planning to license that under the Apache 2 license. So very minimal on with the licensing terms as much as possible there. And so really quickly to conclude, all of this was for us in Cisco and releasing back to the community is to take all of this security specific knowledge that our penetration testers know and our AppSec professionals know to run these tools and try to push that down to the developers. And we know that we can't do that purely through education. We've seen that try to work, but nobody has all the cycles to actually learn all these individual tools. So we want to be able to enable those developers by doing this best effort automation work. So with that, thank you guys, and we'll take questions. Any questions? Yep.
What license are you planning on releasing under?
Apache 2. Yep. Any other questions?
How do you do correlation and deduping?
Correlation and deduping, that is on the feature list. So what we're doing is every vulnerability that comes in has ID tags and things like that. So it's set up for we're going to be able to do that type of work, right? So we're working on that one. Other questions? All right, thanks, guys.